Hi, I'm Miss Hearn. Let's get started. In this video, we're going to count the number of triangles in a complete graph. So what is a complete graph? A complete graph of size n has n vertices, and every pair of vertices is adjacent. In other words, if you look at any two vertices on a complete graph, there will always be an edge between them. The smallest complete graph is a graph with 3 vertices, and even that graph has one triangle in it. The larger the number of vertices, the more triangles that are formed, because any 3 vertices will always form a triangle, since any 2 vertices are always connected by an edge. Let's look at these complete graphs of size 3, 4, 5, and 6 and start trying to list some of the triangles that are in them. I'm going to use a very methodical approach, going in alphabetical order so that I don't miss any triangles and I don't overcount either. So starting with the simplest one of size 3, I'm going to start with the letter F, which is the first alphabetically. I'm going to go to G next, and then to H, and then go back to F. And so I have that 1 3 cycle or triangle. Now let's move on to the complete graph of size 4. Alphabetically, the vertices go in order J, M, O, P. So I'm going to prioritize forming the triangles using this order. So I'll start by listing any triangles that start with J. And even when I'm listing those, I'm going to go in alphabetical order as well. So what I mean by that is from J, since M is next alphabetically, I'm going to list M. And then after M, O is next alphabetically. So I'm going to list O. And then I'm going to go and return to J, and we have our first triangle. Then I'm going to start over again at J. I'm still going to go to M. Now I can't go to O. I've already listed that triangle, so I'm going to move on to the next alphabetically, which is P, and then back to J. So we have J, M, P. So that's our second triangle. All right, so from J, I've already gone to M and then to O, and from M into P. So there's no more JM triangles that I can do. So I'm going to go and start at J again, but this time skip over M and go to O, the next in the alphabet. The only place to go from there is to P and then back to J. So we have J, O, P. Now there are no more J triangles I can make, since if I go from J directly to P, there's no third vertex that I haven't hit already. So I'm going to now move on to M and see if I can make any triangles that start with M. But I'm not going to backtrack to J because I've already listed all of the JM triangles. From M, I go to O. From O, I can go to P. And from P, I can go back to M. So I have M, O, P. Now, from M to O, I could go back to J. But again, we're not going to do that because we're not going to backtrack. So MOP is actually the only M triangle that has MO. I could also try to go from M to P, but then I can't go back to O or J. So there's not another triangle there. So there's not going to be any other M triangles. Now O, then if I only go forward in the alphabet, I can only go to P. From there, I can't go back to J or to M, so I can't form a triangle. So it's not possible to use O, and for the same reason, it's not possible to use P to start an entirely new triangle. In other words, we've already listed all the O and P triangles, so we're done. So the size 3 complete graph had 1 triangle. The size 4 complete graph had 4 triangles. Now, as you can imagine, it can get very long to start trying to list out all of the triangles for larger complete graphs. Luckily, there are a few convenient ways to count the number of triangles in a complete graph. One way is to use the following formula. It tells us to find the number of triangles using this pattern where you add 1 plus the sum from 1 to 2, plus the sum from 1 to 3, plus the sum from 1 all the way up to n minus 2, whatever that number may be. For example, to find the number of triangles in our complete graph of size 5, we're going to follow this pattern up to n minus 2, which would be 5 minus 2, which is going to be 3. So we would add 1 plus 1 plus 2 plus 1 plus 2 plus 3. And we stop there. We stop at the sum from 1 to 3. This is going to be 1 plus 3 plus 6, which is equal to 10. Let's try to use this pattern in a larger graph. Use the formula to find the number of triangles in the complete graph of size 6. So again, This 6 is telling us that n is 6, and we need to follow the pattern up to n minus 2, which is 4. So we're going to have 1 plus the sum from 1 to 2 plus the sum from 1 to 3 plus the sum from 1 to 4. That's going to be 1 plus 3 plus 6 plus 10. So that's going to be 10 plus 10 is 20. So there are 20 triangles in a complete graph of size 6. It turns out we can also find the number of triangles in a complete graph of size 6 using something called Pascal's triangle. If you're not familiar with Pascal's triangle, it's a triangle that can be built based on the idea of starting with ones in a triangular format, continuing with ones down the side, and forming the other entries by adding the two entries above. So 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 1 equals 3, and so on. When we're reading entries in Pascal's triangle, the top row is called row 0, then row 1, then row 2, and so on. In any particular row, the first entry is called entry 0, and then the second entry is entry 2, and the third is entry 3, and so on. So counting rows and when we're counting across rows, we don't start with 1, we start with 0. If you can remember that, then it makes finding the number of triangles in a complete graph pretty easy. All you do is, since we're looking for triangles which have 3 vertices, and since we're looking, and if we know the size of the complete graph, in this case 6, then we're going to look at the third entry in row 6. So you can see here the third entry in row 6 is actually 20, which is the same value that we found before. In fact, all of the values we found up to this point are in this diagonal of Pascal's triangle. This is the number of triangles in a complete graph of size 3. This is the number of triangles in a complete graph of size 4, a complete graph of size 5, a complete graph of size 6, and so on. So if we wanted to know how many triangles are in a complete graph of size 7, it's going to be the next number, 35, which is the third entry in row 7. I hope you found this video helpful. If you did, please give it a thumbs up. That helps other students to find the video. You can also subscribe to my channel, Miss Hearn Mathematics, for more math videos.